Can you give me an example of something that's homogeneous that isn't pure? Can you think of something? Uh-huh. Air. Air is homogeneous, but it's not pure. What else?
Water.
Yeah, water, mineral water. It looks homogeneous, but it's not pure. Like, for example, 18 karat gold. 18 karat gold looks homogeneous. It looks like it's pure gold, but is it pure gold? No. In order to be pure gold, it would have to be what carat? 24 karat. 24 karat gold is pure. But it's very homogeneous. So we have to watch out because that's the first thing we look at usually, because it gives us an indication. You know, if this is kind of where we left off last time. You know, when we're looking at matter, this could be, it doesn't matter if it's solid, like 18 karat gold, or a liquid like water, or gas, like air. You know, all these could look homogeneous or heterogeneous. And so, if it's homogeneous, then we have to be careful, because homogeneous matter might be pure, or it might actually be a mixture. Heterogeneous matter, typically we think of heterogeneous matter as being a mixture, but we also have to be careful there, because sometimes it looks heterogeneous, but it really isn't. Like sometimes raw, uncut diamonds look like a heterogeneous mixture, but it's all pure diamond, or pure, what's diamond made out of? Carbon, just pure carbon. It's just because the crystals look different, and sometimes they aren't really good crystals. And the sizes vary. Like, for example, what were we talking about? Colors being deceptive. Do you remember a case where color was a little bit deceptive? Nothing. Chrome? Chrome? Oh, bromine in water? Yeah, bromine in water. That could be deceptive, because it might look pure, but it's not. The color of the bromine water can. There's one chair up here. Oh, wait. The color of the bromine water can vary depending on the concentration. But it tends to happen with solids. I gave a couple of examples of this. This is why geologists do the scratch test. Geologists do the scratch test because they want a consistent size. Why do the geologists do the scratch test? The geologists will when they want to know what the color is, they don't just look at a crystal and look at the color. They end up scratching it to pulverize it into a fine powder. Why do they do that? Uh-huh. I'm sorry?
Do they want to see if it's like a mixture or like...
No. No, let's say it's pure. They've already determined it's pure. They just want to figure out the color of it. They take a single crystal's pure. Let's say if you have the quartz crystal, or do you remember the crystals I brought in the other day? Those are pure, because in order to be a crystal, what do you know about the structure of crystals? It has to be a regular pattern. That pattern has to be perfect. You know, if there's impurities in that pattern, do you think we're going to get a nice orderly pattern like that if you throw in some impurities here and there? Now what happens is when impurities get incorporated into a crystal, it screws up the structure, and so that you don't get nice big crystals like that. They can't grow that big because all of a sudden there's a kink. And if there's a kink, then it doesn't propagate. I did two. I did two examples of this. One was the scratch test. The other was Nobody remember? Or maybe the connection hasn't been made. The connections usually get made later on after you input the information into your brain. Then you can start making connections. But the connection is, like when you're going through your notes, that's where you can make connections, because I talked about the scratch test early, and then later on I talked about the other thing. Well, actually it was quite close together. Because I talked about salt crystals. Do you like table salt? What color is table salt? White or clear? Now, for a chemist, clear is not a color. Clear just means you can see through it. And so, like, if this is clear, there's no contaminants in there. Like, for example, when I was doing the ethanol fermentation, it wasn't clear. It was very cloudy. That means there's a whole bunch of other junk in there. And for sure that was a mixture, because that was quite heterogeneous. It was cloudy. But this one, this is clear, but what color is it? It's clear because you can see through it. But the color would be blue. And so to a chemist, clear is not a color. Clear just means you can see through it, and it can have a different color. And so if it doesn't have a color, we call it colorless. And so what was the color of the salt? What color does table salt look like to you? White. But is it really white? No, because if you look at an individual crystal of table salt, just pick one crystal out, it's actually colorless. It's just white because of how it interacts with light. And so, do you know what color is copper? Red-orange, like a copper penny? Let's say red-orange. But if you have a tiny crystal of copper, do you know what color it is? It's black. In fact, tiny crystals of most metals are black. Like a tiny crystal of gold is black. And so color is deceptive because color depends on the size of the crystal. So if you have a mix of different size crystals, even though it could be pure copper, you have a mix of different size crystals, they might give the appearance of heterogeneity, at least for the color, whereas it's still pure. And so that you have to be careful, because sometimes you can be deceived into thinking it's a mixture, whereas it's actually pure stuff. And so we talked about, and so the whole purpose of the scratch test, what was the whole purpose of scratching it? Because you could see the color right here. There's no need to scratch it. And the whole purpose of scratching it is to get a consistent size crystal. You're breaking that big crystal into lots of tiny crystals, and then you get a consistent size crystal. Then it's fair to compare the colors, because it's not a fair comparison to compare the color of a big crystal with tiny crystals. It's not right. So if I had a big crystal of table salt, it would it would be totally clear and it'd be totally colorless. You could see right through it. And so these are the types of things that you want to review. Like I said, the exams at UCLA are timed, and so if a question like this came up, is it at the top of your memory or not? Or can you make connections with other material, like the scratch test versus table salt, that kind of stuff? Is there any connection there or no connection? And so this is why it's good. We're reviewing it now, but you should review it right after class. But let's continue. What else did we cover yesterday? What were some of the key points you should remember? Well, pure substances for sure we want to know, because if it's pure, then what can it be? An element or a compound. Good. So pure substance. Element or a compound. Okay, what else did we do? Yes, sir. If it's a mixture, then it's going to be a mixture of elements and compounds. Heterogeneous is typically a mixture. Okay, what were some of the other key points from yesterday? Uh-huh.
Distillation and filtration.
Yeah, distillation and filtration. Distillation and filtration are techniques that are used to do what?
So take out impurities.
To take out impurities. In other words, they're used to separate out the mixtures into pure components. Okay? And so we call those physical separation techniques, or physical separations. And so we had distillation and filtration. Any others that you recall? Condensation. Condensation is part of distillation. The condensation, actually, if you looked at that figure carefully, one of the parts on that figure is called the condenser. Now, I didn't name them, but there's a condenser there to help condense the gas into a liquid.
Is there chemical separation as well?
There's chemical separation, but I want one more physical separation technique, or more, as many as you can tell me. Uh-huh. Yeah, reverse osmosis is one as well. Reverse osmosis you can use to purify water. It'll separate out the water from the salts that are dissolved in the water. So reverse osmosis, that's a good one. Used for water purification. What else? You know, you got to think. You might think, there's always, like, studying for exams is always a bit of a trade-off. You know, you think, will that come on in the test or won't it? You know, because there's only a certain amount of stuff you want to hold in your head, and so you could sacrifice it or not. And so if something came up, list as many separation techniques, well, you might think of some new ones like that, but at least you should come up with the ones that were discussed in class. So can you think of one more that was discussed in class?
Electrolysis.
Electrolysis is not. Electrolysis is not a physical separation. Electrolysis is a